Hi everyone, this is Andrew. This will be my first algebra lesson, and today we'll be looking at the quadratic equation and how to solve it using factorisation. So first of all, what is the quadratic equation? Well, the quadratic equation there's a single variable, in this case there's x. There's a single variable and the highest power is 2, right? So there might be the second term, so we've got bx here. There might be this or there might not, it doesn't matter. The key is that there's an x squared term. Now this form here, ax squared plus bx plus c equals 0, that's the standard form. Today's goal, to use factorisation, is to get it into this form. So we'll have an x here and an x here, or some quantity of x there, plus something, plus something. That's factorisation. The reason we want that is so that we can solve for x. It makes it easier to solve. Okay, so let's look at some problems. The first problem, x squared plus 8x plus 15 equals 0. Okay, this is a rather trivial question, but it's to learn the foundation, learn the basics. So, what do we need to do? Well, the key here is to find two numbers that multiply to get 15. So two numbers that multiply to get 15 and add to get 8. Right? So can you think of two numbers that multiply to get 15? Well, the only ones I can think of, well, there's 1 and 15, of course. Let's try that. So 1 times 15 equals 15, so that's fine. Now what does 1 plus 15 equal? 1 plus 15 equals 16. Now this 16 does not equal that 8. So that's not correct. All of this is not correct. Okay, what's two other factors of 15? 3 and 5. 3 times 5 equals 15. 3 plus 5 equals 8. Yeah, that's right. 3 times 5 equals 15. 3 plus 5 equals 8. Great. So in order to factorise this, all we do is put our two brackets, put an x in each side. Now we know that it's positive 3 and positive 5, positive 3 and positive 5. And that's it. It's factorised. And you can double check that by, expanding this. So remember, you expand by multiplying each term by each other term. So x squared plus 3x plus 5x plus 3 times 5 is 15 equals 0. And of course we can see that if we add 3x plus 5x, we'll get 8x. So our final result would be x squared plus 8x plus 15, which is what we wanted. So what can we do with this? Why did we get it into that factored form? Well, so x plus 3, x plus 5, just remember that. X plus 3, x plus 5 equals 0. The reason we do that is because it's much easier to solve. Can you see, for this to be true, for something, so something, all of this in brackets is just something, something times something equals 0. One of those somethings, so either this one or this one, must equal 0 for that to be true. Or they could both equal 0, right? So anything times 0 equals 0. So to solve for x, we'd go x plus 3 equals 0, we know that. Or x plus 5 equals 0. X plus 5 equals 0. Now we can solve, that's a fairly trivial thing to solve, isn't it? So x will equal minus 3 here. Or x will equal minus 5. And you can go back and check that with the original equation. The good thing about algebra, generally, is that you can always check your answer. You can always see if you're right. Okay, let's do the second problem. X squared plus 4x minus 21 equals 0. Right? Okay, so we need to find two numbers that multiply to get minus 21. Two numbers that multiply to get minus 21. What would your guess be? My first guess would be 3 and 7, with one of them being negative, right? So what do you think? Minus 3 times positive 7 equals minus 21. Minus 3 plus 7 equals positive 4. And that's correct. Positive 4 is what we're after. Minus 21 is what we're after. So the factorized form would be x plus, that's okay, x plus 7, x minus 3. And if you go ahead and expand that, well, we'll just do it in our head. So x squared plus 7x minus 3x is 4x minus 21. That's correct. And all of that equals 0. So again, it's easy enough to find x, find the value for x. It'll be either minus 7 or 3. Good. Let's do a bit of a harder problem now. What if there's a number in front of the x squared instead of 1? So previously we had a 1 here, didn't we? Or just x squared by itself. Now this makes it a little bit trickier, but there are techniques to solve this. So 2x squared plus 9x plus 9 equals 0. Now here you can't use the method we used just before. We can't find two factors of 9. Two numbers that multiply to get 9 and add up to get 9. We can't do that because there's this 2 here, isn't there? So a technique to use is to multiply the a term, so that's the a term, by the c term first. So multiply the a term by the c term. Right? 2 times 9 is 18, and that is our target. 18 is our target. Right? So we need to find two numbers that multiply to get 18 and add to get 9. So exactly the same thing we're doing before, except that we first multiply a by c, 18. We need to find two numbers that multiply to get that and add to get our initial b. Okay, so what's two numbers that multiply to get 18? Well, there's 2 and 9, isn't there? Let's try that. So 2 times 9, I'll just try it over to the left a bit. 2 times 9 equals 18. 2 plus 9 equals 11, which is not equal to 9, is it? So that's wrong. That's wrong. How about 18? 6 and 3? 6 times 3 equals 18. 6 plus 3 equals 9. Yes, that's right. 6 times 3 equals 18. 6 plus 3 equals 9. Now, what do we do with this? So we know that the factors here are 6 and 3. Well, what we need to do is rewrite the original equation. So let's do that. Rewrite the original equation, the one in yellow up the top there. But instead of writing 9x, we break the 9x up into 6x and 3x. Can you see that that's equivalent? 6x plus 3x plus 9 equals 0. Can you see that 6x plus 3x is the same as 9x, isn't it? It's identical, it's just breaking it up. So we use that technique to identify how to break it up, right? Okay, so knowing that, what do we do? Well, let me just move the page a bit. Okay, so we've got that. What we need to do now is take the first two terms and the second two terms and find a common factor. So let's look at the first half, okay? So the first half, what's the common factor of 2x squared plus 6x? Would it be 2x? Yeah. So we can put a 2x out the front. 2x times what equals 2x squared? X. 2x times what equals 6x? 3, right? Okay. So we found a common factor of that first half, those first two. Now the second two terms, let's find a common factor. What's the common factor of 3x of 3x and 9? Well, 3, isn't it? 3x plus 3. Now can you see that we've got a common term here? That happened because we used that technique to divide 9x into 6x and 3x. So this will, as long as it's a trivial example, as long as there's no fractions involved, then this technique will be useful in the situation. Okay, so we've got a common factor here, so let's put that out the front. X plus 3 times what? Well, so the common factor here is x plus 3 here, and x plus 3. And then the other factor would be 2x plus 3. Can you see that? So another way of rewriting 2x, so a way of rewriting 2x, x plus 3 plus 3x, 3x plus 3 is this down here. X plus 3, 2x plus 3. And believe it or not, that's our answer. That's our factored answer. That's the correct factorization. You can go ahead and check that. So for example, 2x, I'll just do it quickly, 2x times x, so 2x squared plus 6x plus 3x plus 9. So that'll give us 2x squared plus 9x plus 9. So, and then we can go ahead and solve that. Let's just do that for completeness. So x plus 3 equals 0, or 2x plus 3 equals 0. So x will equal minus, x will equal minus 3, or so 2x will equal minus 3, x will equal minus 3 divided by 2. So the answer is minus 3 or minus 3 on 2, and you can go ahead and check that if you like. Good, let's do another problem. 3x squared plus 13x. I'm slowly making these harder as we go. 3x squared plus 13x minus 10 equals 0. So again, we've got a value for a, which is greater than 1, so we need to use that technique again. So remember, what do? We multiply a by c. So that'll be 3 times minus 10 equals minus 30. That's our target. We have to find two numbers that multiply to get minus 30, but add to get 13. What do we think? 10 and 3? Possibly. 5 and 6. Let's try it. 10 times minus 3 equals minus 30, but 10 plus minus 3 equals 7. That's not right, is it? What's two other numbers that multiply? They have to be negative, don't they? So what about 15 and 2? Let's try that. 15, because it's positive 13, I'll know that'll be positive 15. It has to be high positive, doesn't it? So how about minus 2 times positive 15 equals minus 30. Minus 2 plus 15 equals 13, right? So that's correct. So the two factors are minus 2 and 15. So remember what we have to do. We have to rewrite the initial equation, 3x squared Now instead of writing 13x, we need to break it up into minus 2x plus 15x minus 10. Right? Because we've used that, minus 2x plus 15x. It's exactly the same as writing 13x, except that we've broken 13x up into minus 2x and 15x. Okay? Right. So the next step is to, remember, to group the first two, group the second two, and try to find a common factor in each. Right, 3x squared minus 2x, what's the common factor? X, right? There's only x that we can take out of that. X will leave us with 3x minus 2. And the second one, what's the common factor with 15x minus 10? 5. So 5 times 3x minus 2. So we can see that 3x minus 2 is the common factor here, so we can put that out the front. 3x minus 2 and x plus 5. Remembering x plus 5 came from here, x plus 5. And that's our factored form. Equals 0. So you could solve that. You can double check it. So 3x times x is 3x squared minus 2x plus 15x is 13x. So minus 10. So we'll get the original equation 3x squared plus 13x minus 10. And you can solve that as per, making this term, so 3x minus 2 equals 0 and x plus 5 equals 0. So or x plus 5 equals 0. Let's do the last problem. 6x squared plus 17x plus 7 equals 0. Okay, again, we've got a term other than 1 out the front here, out of the front of the x squared. So we have to use that technique again. So remember a times c. So 6 times 7 equals 42. 42. Two numbers that multiply to get 42 but add to get 17. 14 and 3 is what I thought of. So 14 times 3 equals 42. 14 plus 3 equals 42. No, it doesn't. What am I talking about? 14 plus 3 equals 17, which is what we wanted. So that's correct. Rewrite the initial term. So the initial equation, 6x squared plus, so we want to break the 17x up into the new ones, the newly found factors. So 14x plus 3x plus 7. So this is equivalent to this equation. It's identical, except that we've broken the x term up. Okay. And now we can go ahead and group. Oh, apologies, I got to the end of my blackboard. That's all right. Go ahead and group this one and this one. So 6x squared plus 14x, what's the common factor? 2, is it? Let's try that. 2x. So that would be 3x in there, plus 7, plus, what's the common factor for the second one? 3x plus 7. There is no common factor, is there? So 3x plus 7. Okay. So we can go ahead and put that out the front. 3x plus 7 multiplied by 2x plus what? 1, right? And that should be our final factored form. Let's go ahead and check that. 3x times 2x is 6x squared. That's correct. 7 times 2 is 14x, plus 14x plus 3x is 17x. That's right. And 7 times 1 is 7. So we'll get our original equation of 6x squared plus 17x plus 7 equals 0. And you can solve that as per what we've done before. Okay, that'll do for this lesson. Next time we'll talk more about completing the square. So that's another technique to solve more complex quadratic equations, and possibly using the quadratic formula, which I don't like to do, but we'll have a look at that too. Okay, thank you.